in London. Yeah, so did you manage to?
No.
Okay.
But I've run out of ideas now.
So give me just a moment, guys, just to get in, and we'll start the presentation soon. I'll share my screen. Phil is already on the event. Guys, can you? Yeah. So Phil is going to speak out from my laptop, and he's going to share his screen.
Thanks. Okay.
Do you need to extend the screen?
Yeah,
They are not?
they can.
Okay.
Good.
On fly. Yes.
Okay. What's this up? Looks like the network operations of. Okay.
Okay, you can.
I've got a presentation on that.
Yeah. Carlos, I just ask if they are seeing the presentation also, please.
Okay. Can people see the yeah, I can see what people can see. I've got a monitor. Good evening. My name's Phil Marson, and I've been working for ISP Global for the last nearly 2 years now. I've been told I'm not allowed to plug the company. So just very briefly, we deliver software into waste management and recycling and metals trading environment. And you know, with a traditional ERP system like SAP or the Oracle ERP systems, they do all the things that every company needs to do, and you just try and do it as quickly and efficiently and cheaply as possible in a standard way. But in every industry, there's some things that are specific to that industry, and our products sit in that space, so sitting in front of ERP systems, but working doing the things that you need to do in waste management. This demonstration is not going to have a lot of OutSystems in it because I'm not an OutSystems developer. But what I'm going to talk about, and there's some of my team on the call, and they'll tell you how bad an OutSystems developer I am. What I'm going to talk about tonight, though, is that there's a challenge that faced us when we were developing this software of making small devices at the edge of the network, typically at refuse sites and landfill sites and recycling units, and getting the hardware that's there to talk to cloud-based systems. And I'm going to I'll talk a bit about the device manager, which is the small computing device that I designed and we implemented that uses AWS technologies to interface those devices to a cloud-based system. I'll talk a bit about why that's why that's a non-trivial thing to do. So, it's years since I last gave a presentation. I think I've just said most of this, and the demonstration will be mostly in AWS, but there will hopefully be a bit of an OutSystems application at the end. And the fundamental issue is OutSystems makes integration with other large systems really easy, because with our WR1 product, we know where S4HANA is going to be, and it's not going to move, and there's only one of it. Whereas with something like Scale on a landfill site, they come along and they go away, and they reconfigure, and you probably don't want to have your network open, so that they do tend to be IP enabled, but you probably don't want to have your network open, so anybody using a browser anywhere can get all the way through to your remote site and access the Scales directly. So that's the challenge, is how do we integrate with a lot of things which change quite quickly, may or may not be there at any particular time of day, and do it reliably. So I talked briefly about the way which I'm going to aim to end about 10 past or 7. Is that about right?
Yeah, that's fine.
And this is our picture of the Weybridge of the future, and most of this already exists on the site, so some of it's a bit speculative, but in common with everything else, the idea is that we'll provide that everything will be attached to the network, and it'll be automatable, and it'll be sending signals out, and you can, systems can make requests of it, and it'll generate data, so you can run everything more efficiently, and it'll enable people to do self-service. And just make things a bit easier. So the things I'm going to point out on here, we've got this lorry sitting on a Weybridge, and I'll show you our test Weybridge. Got a picture of our test Weybridge later. There are cameras. There's some really interesting. Cameras are used for a few things. Mostly they're used just as systems of record. So when somebody pulls up in a truck, you go, well, that truck was here then. How many people here work in finances? You were in London. Finance workers? So you're familiar with Know Your Client and anti-money laundering stuff. When you're buying metal off people, you have to do the same thing. If somebody pitches up with a truck full of copper or lead, you can't just give them money for it. You have to, because it may not have come from a property that they wanted. So there's an amount of record keeping. But also, shockingly, people sometimes turn up with trucks which ostensibly are full of a high-value product like copper, and it all looks like copper on top, and you sort of dig into it, and there might be some baths or packets of concrete or something, and they're paid by the kilo on the Weybridge. So it's really nice to be able to pack the products out. So take cameras just to get some investigation and some record on there. So some other companies have been doing some really interesting stuff about automatically recognising what's in the truck from the camera. We've got barriers which you might want to control, and traffic lights, and I mentioned the Wade Bridge. You can't quite see it in here, but we take electronic signatures and attach those to contracts. And you might have power being generated or other environmental factors that you want to measure. For instance, radiation. It's quite nice to know if somebody turns up with a truck full of low-level waste before you throw it in the ground. So the trends are to self-service, to automation, to low-touch processing, and to use all of that to enable better regulatory and legal compliance, and to do it as quickly and smoothly as possible. The last thing you want is a load of lorries waiting to get onto your site, because those drivers aren't doing anything productive while they're there. A lot of them are self-employed. If you get a reputation for being slow to get people on site, they'll take their material somewhere else to sell it, and you'll annoy your neighbours. Probably slightly more than you would by just having a landfill on their site. So it's all about exactly the same things as the retailers want to get you through the tills quicker. There's a move to self-service, which was initially about economy, but now is about there just aren't the people to do it. I don't know if anybody's been in a supermarket recently, and so that's what we're trying to achieve with this. And so I mentioned some of the devices earlier, and this gives us a sort of logical classification of them. Facial recognition, I forgot to mention that on the camera. Number plate recognition, facial recognition are great, because when some customer drives up in their truck, we know that truck, we know who drives that, we'll bring up their work order or their account. Somebody walks into the office, and you can do, I don't know how legal that is, and we haven't implemented it, but it's something that people have asked for. I talked about environmental monitoring and the radiation detector, and because this is a technical audience, I've done that as a UML diagram as well. Don't expect you to be able to read that. Simple class diagram, and basically, well, there are things where you can just say, I want to know what the current reading on is. Tell me the reading on that Wade Bridge. What's the signature that has just been entered on that pad? And there are other devices like video cameras and some types of scales which just continually publish information. They stream the information out. You want to be able to process that. And then lower down, you'll have devices like scanners, but there'll be specialist ones for ID scanners. I don't know how. That wasn't the right button, was it? So
It's still sharing files?
You share that screen.
yeah, I can see what you can see, but I can't.
Step through the application back here.
Yeah, back in.
Come on. We're back. And so this insight about this hierarchy and design was used to enable us to develop the software very quickly. But I'll come on to that. I mentioned earlier that I didn't mention earlier that each of the different devices from the different manufacturers tends to have a different protocol. And different ways of talking to it. Some of them horribly require Windows drivers that haven't been updated for 10 years. Some of them, most of them, you can just connect directly to the port and then exchange characters with it and then pass them and so on. And the locations of these sites, by their nature, tend not to be in the busiest and nicest parts of town. And in countries like Australia, it can be a very long way from decent network connection. So you want something that will work okay without network. There's an aspiration to move to a bit more local stuff. But then again, if you're running your ERP system on the cloud and your network goes down, you haven't got any access to the rest of the system anyway, really. Yeah, absolutely. That's the fallback. It's one of the fallbacks. So our solution was to our solution was to build a stateless C#.NET application on top of AWS services and using AWS IoT for the most part for asynchronous messaging, which works nicely. And in particular, it means that nothing needs to know where anything else is, and they don't need to talk. None of the components need to be able to talk directly to each other. They only have to be able to talk to the message hub. One of the things you can't do when you're running an architecture like that is to move very large objects around. So we use S3 for images. So hopefully, when we get onto the demonstration, you'll see me sending a message that goes, "I want an image from that camera, please." It connects to the camera, takes the picture, stores the picture in S3, and goes, "Yeah, I'll put it over there." And we've used the Elastic container registry for deployment, just for distributing the software.
How are you dealing with the event then that a truck pulls up, sits on the scale, you're filming it at the same time, there's electronic signatures done at the door, like you're using the timestamp to recognise all those things are happening at the same time?
There's a scale operator running an application which pulls it all in, and you'll see me getting a weight later. Unfortunately, I've got a test rig with all of that stuff on it, but the idea is they go take signature, take image. If it's a streaming camera, it might be just copy the image that we've got now.
Okay, so you're basically telling it to do a thing,
Yeah.
rather than just continuously sending you stuff. You've got to work out how to join those events.
That's right. I mean, we can cope with that sort of thing. So for something like radiation, if you've got a radiation detector, which is just continuously publishing data, we can just sit there gathering the information in, and then messaging it on, aggregating it, because you don't want to send huge amounts of information. Maybe averaging it over an hour and then sending it to an operational data store or something like that. Because with the radiation detector, you'd hope that the people who sold you the detector had something that would start the bells ringing immediately.
Yeah. Okay.
So
the device. Okay.
Yeah. So, and one of the benefits of the .NET architecture is that it runs nearly anywhere. Particularly if you then put it into a Docker component, a Docker container rather. And in a moment you'll see me starting one up on a Raspberry Pi just to prove that they can run everywhere. You'll have to take my word, there's a Raspberry Pi sitting under my desk. It's slow enough, I'm sure you'll believe me. And so just a simple context diagram. This is the device manager that sits here, and it's. I'll talk you through the startup process, but it subscribes to a load of messages from the hub as it starts up. It actually gets its configuration from our product, or it can do. I'll be running in standalone mode mostly today. And that means that if you want to change the configuration, you change it centrally. And there's no state on the device manager. So I mentioned that these very horrible locations, they tend to be quite dusty and hot. You could have a stack of Raspberry Pis, identically, it's stored in the cupboard somewhere. If it breaks, there's no state on it, doesn't matter, swap out the dead old one, put the new one in, fire it up, it'll go.
Is the Raspberry Pi local to the device that's doing the sensing, or is it managing multiple devices?
The ideal is to deploy it on the site. No, the ideal is not to deploy it on a Raspberry Pi. That's really me showing off. But you can if you want. But the idea is to have a device manager on the site as close to the devices as you can to keep the latency down.
Okay.
You don't have to do that. One client's deploying a single device manager on an EC2 server in an AWS VPN, and that's going to manage all of the scales everywhere.
Okay.
Works perfectly well, I hope. And then so you've got the site devices down here with the device manager talking to it, and browser-based application for the front end or on a tablet. But the crucial thing is, most of the time they don't talk directly to the site devices. They'll use the same messaging protocol as the server if they need to. And again, I'll show you that later. But sometimes the request might just be, I know there's a camera there. tell me what URL I need to use in order to get to it. So you take that configuration out of its file applications and keep it all in here.
So is the true art here that within the device manager, you're writing functions that can talk to all the myriad of protocols and all the myriad of devices that you may have to come across to the client?
Exactly. Yeah.
Okay.
So for things like scales, most scales,
Yeah.
well, they have two modes of operation, but a lot of them, you connect to them, you send them an instruction over a very simple socket connection.
Yeah.
It's usually W followed by a carriage return character, but it's often enough that it isn't, that causes a pain. And then it sends a message back to you, which will be a string of characters. Somewhere in there is a weight. If you're really lucky, there's a unit of materials as well.
Okay.
So you know what the denomination of that number is. And sometimes the serial number is one thing. So what we've set up a fairly general configuration where you go, well, for that scale, the weight comes in the 9th to the 15th character, and the unit of materials is in the 20th and 21st, or something like that. So we try to make it as general and configurable as possible. For things like signature pads, where every driver is different, it all gets a bit worse.
And are you introducing these devices more often to the site as part of a deployment or as part of the work you do with them? Or do they come to you with a variety of devices and you have to just roll what's there?
It's a bit of both. If people are looking to roll out a new ERP system or a new WR1 system, the chances are they're upgrading quite a lot of their processes, and they'll want to upgrade their site at the same time. Yeah. Something like a Weighbridge is very expensive to install, and they go for decades. Okay. So they're unlikely to be getting a new Weighbridge at exactly the same time.
It's like cameras might be something you could
yeah, exactly. The cameras are actually surprisingly easy to integrate to, because there is a number of standards for that, but not a huge number of standards. So one of the things I really like doing is saying what I'm going to build before we build it. So I don't know if you're probably familiar with swagger.json that OutSystems produces, which is the Open API specification, and there's a very similar specification for asynchronous messaging systems. So we've designed our API in that language, and we use it to generate bits of the device manager, but also it acts as our contract to the WR1 developers. We go, this is how you ask us for services from the device manager, and you won't be able to see it. So I'll talk about it in a moment when you will. But essentially, this is a set of messages. And I've been working with some OutSystems generated REST APIs on another project recently, and I quite like the way OutSystems generates the swagger.json, but it's not a very sophisticated specification that it puts out. And one of the things I did on that project was to bring a definition of under version control, and when the OutSystems developers changed their API, I could go back and go, no, that's not what you said you were going to build. So, the implementation challenges. So I realised I've got 15 minutes now and I haven't even started the demo. I've talked about manageability with everything being stateless, but there's a load of services in here, and we'll hopefully see some of them where you can interrogate the device manager. So you can say, actually, what do you think we've got? Stateless operations, so we can swap things in and out. Active passive clustering. I've got 4 different options for clustering resilience. Each device manager, as it starts up, is told what its name is. And the first thing it does is it goes, is anybody out there answering to this name? And if something else does, it goes, fair enough, I'm stopping. So that's really, really basic. But of course, once you're running things in a Docker container and composing things, you can use Docker swarms. There's all manner of stuff on AWS.
So you're saying at the physical site, you may have a bunch of machines doing either just sitting there waiting to fail over something.
You could do. I wouldn't advise it. That was our first stab at clustering. But
okay.
But what you don't want, that's it. Nothing knows where anything else is. All it knows is that something's fielding requests. So what you don't want to happen is for 2 device managers that both think they're operating under the same name to be coming up, because then somebody's going to send a message saying, "Tell me that device manager. I know the scale is attached to that device manager. Send me the weight for that scale," and then have 2 things answering it. Like the man with 2 watches, never quite knowing what the time is. if you start getting double messages back from the scales, it's one of which is an error, probably, then it's not going to be great.
So what did you arrive at then to manage redundancy?
I would recommend using the Docker Swarm.
Okay.
So all of that stuff that I was just described was unnecessary, but it was a step we went through to get there. And then in OutSystems, sending messages is easy, but subscribing to them coming back was difficult, and that took a bit of a shim. And I'll put a picture up and hope that nobody asks me too many questions later. Do we have anybody who actually works for OutSystems here? Excellent. I'll come back to that. So live demo. This is so. That's the one. I hope. Right. Now, what I've done is I've set up. I've got 3 device managers which may or may not be running, I'm just going to. I'm going to go to the one on the Raspberry Pi, and I talked about. Talked about the.
So what is this demo about?
So I'm now going to send a message. I've talked about this protocol. Oh, I forgot to mention that the AWS IoT functions that we're actually using. But does anybody know much about IoT? AWS IoT in particular. They at the root of it, they have an MQTT style publish and subscribe messaging architecture, and then they build layers of architecture on top of that, so you get to manage devices and automatic deployment and remote SSHing into them, and then they charge you for those bits. And we looked at it, we couldn't see any great benefit in using all the managed device things at the sort of scale that we're working at. And so we're just using this publish and subscribe messaging protocol. And this is just a test client for the publish and subscribe protocol.
When you say at the scale, you were too big or you were too small?
Too small. So I've worked in a previous life with a German manufacturer that make machines for creating synthetic materials, and they'll fit out a factory with 1,000 machines in China. And at that scale, you really do want the AWS IoT device will create a sort of a virtual image of what's going on the real machine. But we're just too small. We're not going to be managing huge farms of these things. So, unfortunately, so if I send it to the messaging structure takes a site, the device manager name, and then the request that we want. And then there's a verb on the end to get. And the reason, and if you've used these messaging systems, that it's just a hierarchical naming convention. And the way you design it is so that the response either comes back as an accept or a reject message. If you get a response, you don't always get a response. So you immediately know whether there's been an error or not based on what message, the topic of the message that comes back.
But you're not sending some sort of ID to say, and let me know that this response is associated with the request.
No. So,
Hence, I can start seeing the complexity here.
Now, I'm probably not going to get anything back from that because I'm not actually running the device manager at the moment. And so I've logged on here to the Raspberry Pi. I'm not running it. If I turn in and go to so the device manager is running up now, and stuff will come past, and I'll point to it quickly. Starting with the name PyDM, so I talked about earlier how everything knows what it's called. This is running in standalone mode. In a moment.
So if you're running the farm and say, like, you've got 4 sites connected to your central control platform, Are you also a layer which is monitoring, which is detecting which devices might be down or which things that?
That's a bit of infrastructure we haven't yet built, but we've got all of the facilities necessary to do that, and you'll see that in a moment. So it's got off the screen now. It loaded in the configuration from a local file, and then it started subscribing to messages. And plus is a wild card. So it doesn't matter what site people are asking for. I'm interested in anything that's coming to me, and this is getting me scared. So that's give me the picture. There's about half a dozen of those. Then it starts going. It does the stuff where it says, "Is there another one? Anything else running with his name? No, it isn't. Everything's fine. Right, I'm up and running." If I come back to here. And I think I should probably subscribe to that in capital letters. Yeah, as I should have done. Sorry about that. I just sent that get status message again to it, and you saw how quickly it came back with the response. So that message has gone off to the data center, well, wherever this browser, the web server this browser is running, which is probably the AWS data center, out through the network, down to the Raspberry Pi and back again. But and here you asked about the management console earlier. I can see from this software build that I've got how long it's been up, last time the configuration refreshed. Some metrics about how quickly it's running, how quickly it's doing the services, and also some stuff. Well, what sites is it configured to manage, and what types of signature pads can it manage?
Just rather than a poll or some sort of thing where you haven't had traffic for an hour because no one's turned up the site, you can quickly check those devices.
Exactly. Yeah. So you can imagine having a really nice graphic chart going, yeah, just update it every 30 seconds or every minute. So, just clicking on. I'm going to start editing now. Right, so I'm going to go to the GitHub integration test. And I said about how you can interrogate things. Oh, and I've got an error. Unable to fetch devices, and that's because I didn't get the site right. So I talked earlier about structuring them, structuring the topics. So that there, I immediately I've got an error. Tried again. You'll notice that it doesn't matter what I've got in the payload so far. Now I said, well, what integration device manager? What devices have we got at the Bavarian site? I can show you some more. I can get it to describe what configuration it thinks it's got for each of the devices and so on. But we haven't got enough time for that.
We want to time it.
Okay.
So.
Fine. I don't know how interested people are in this, but
So let's say someone said we want to do something with IoT. Let's say you were going to a brand new site and designing the site.
Yeah.
So it feels like your experience has dictated that there's so many different protocols and so many different capabilities of the various technologies you can put into this place.
Yeah.
And from an OutSystems perspective, talking to whatever those protocols are, it's a big challenge.
Yeah.
So you really need to build your own device manager to sit between that and broker that layer, which will obviously go into goes to AWS, and then you can do the piece on that. So if I've got a mobile device and I say, so I think the example you were talking about was like truck turns up and I press a button and say, wait, truck, and it grabs a picture of the truck, Because picture the guy driving the truck, it weighs the truck, and then maybe if you're really careful, it's got a camera on top and it's trying to work out what's inside, or it's running extraction, or whatever.
Yeah, exactly.
It's
Yeah.
doing, right?
Yeah.
And there's a radiation snap all at the same time. So that message is coming from your mobile app, the OutSystems app, pushes out to the OutSystems cloud, then talks to AWS, pushes that message down to the device managers. They then do their thing they need to do. They get their responses. They come back to the device manager, back to the thing. So is it possible that, how do you manage the synchronicity of those? Because how does OutSystems know, or how does it know how long to wait for the message to come back and all those sorts of things?
No, I mean, that's part of your error handling. When you send the message out, there's various things, various failure modes. I mean, you just covered all of them. One is you get the reject message back, and you didn't understand that. One is you get no message back at all. So you do have to set up the timeout. As part of that. And the way we've actually implemented it for getting the scales in our product is the message is not sent from the OutSystems on the server; it's sent from the browser in JavaScript.
Okay.
So that takes out some of the latency that we're talking about. But you're absolutely right. You have to cope with that situation, and then you have to make sure that it was a message that was related to the thing you're asking for. But yeah, it comes back. It doesn't. The message that comes back, and we'll see one in a moment. It doesn't just go, the weight was this. It goes, well, it's come from this. It's come from this device manager, and somewhere in the answer would go, and the scale that I'm looking at is this.
Okay.
So you can.
So being completely novice to this and not having any experience in it, I would kind of imagine this an architecture like what you do with like Python models and these sorts of things. We're going to throw a bunch of data at a Python model, and eventually it will finish doing its calculations and want to send them back to you. So the way you typically set that up is you basically say, here's my callback URL, with my API that I'm going to post. When you're done, tell me you're done, and then I'll go and fetch the data off you once you're happy done that sort of thing. And that's how you kind of deal with that.
Except it's not even a callback. It's just I'm sending you the message. I sent you the message. Get devices get. And when you're done, send the message. Then get devices get accept.
Okay.
It's exactly that.
So
Exactly that sort of thing.
But you're never really going to end up in a situation where you've got two operators trying to weigh the same truck at the same time for the same two devices. It's going to be a much more contained situation where you're not going to. You shouldn't
have that. But
okay.
if your user interface only starts listening to the message, the weight messages after you've hit the get the weight button, then it'll receive the first one. The next one will probably just disappear.
So in terms of then, do you see there's an emerging, because obviously IoT is something that we've been banging on about in our thought pieces for a very long time, right? But what I think you're suggesting from your experience is, sure, but there's 1,000 different companies doing 1,000 different things, and there are protocols, and some of them are very lightweight type text-driven things. It's not sort of like you haven't held HL7, these sort of standards, which are just an XML definition type thing. These are like almost like a command line type thing. Is there a protocol you're seeing, or is there a thrust where you see I can grow a bunch of devices and they all talk the same protocol? They have that sense. It's just not there.
No. That hasn't even happened on classes of devices. Somebody tried that at the turn of the century for weight bridges and scales.
Right.
You can still find the standards out there.
Okay.
Can't find any implementations of it.
Okay.
But one of the other advantages of this, when you start to talk about the information the data science type thing, because it's a publish and subscribe mechanism, anything could be listening as long as it's got the right credentials. So you could imagine having a listener that goes, actually, I just want to know about every scale reading that's taken today. And I know where it's come from because it comes with enough information from it, and I just stuff it in an operational data store and then into a data warehouse. And then I've got a massive amount of information about the efficiency and operation of my sites. None of that has to go through OutSystems or WR1. So having this small device, small computing device, fronting these physical devices opens up the information that those machines are generating to very easy analysis and access from any application. I've drawn up a value chain which starts off with get information from the small things like the device manager, and you can buy IoT devices which have already got bits of that functionality in there, and you configure them. They'll just flow meters or something like that, which just send out messages on the same information bus that we do. And I haven't got the slide with me today, but I've created the value chain which says how do you get from those sorts of devices all the way up to the sort of predictive analyses that are really going to give you business benefit and enable you to predict failure and do timely maintenance.
Because I think that's
but we haven't implemented all that yet.
That's the use case really, which is just continuous data being pumped from like all the lights in the building to tell you when it's going to fail and you're going to replace the light.
And there are some standards for that that sort of thing. But there's this plugging into, but you have to you tend to buy new products for that. This gives you the ability to do it to your old big heavy devices, or really cheap devices. I've worked out a way to make the device manager talk to just about any IP-enabled camera, and then stick ANPR on it. If you go out and buy those are moderately expensive.
So in terms of the cost in the stack, so the equipment will probably need to be there anyway because it's some cost by the client to that kind of bits and pieces. You're then bundling up these device managers, which may be anything from a Raspberry Pi to like EC2 and some of the physical hardware.
Well, we don't sell the hardware, but
in terms of those, okay, so you don't sell the hardware, but you're just saying here's a Docker component to deploy it on a thing.
We'll work with you as part of the deployment of WR1. We'll work with you on planning your sites and wiring that stuff up.
Okay. So in terms of the cost though, so the hardware is kind of like a sunk cost. So it's kind of like a capex cost that's going to happen when you deploy that thing.
Yeah.
You've got your continuous AWS subscription costs that you're going to be running, and as you scale up, it's go up, and as you scale down, it go down.
Yeah.
What other costs exist in the stack? So your OutSystems licensing, that's another.
There's the AWS costs.
Okay. So there's an OpEx cost for AWS, and CapEx for the device managers.
Yeah.
And then everything else is just software and labor.
Pretty much. Yeah. Cool. And the AWS cost is very small. I mean, these messages are sold by the millions for a handful of cents.
And did you look at other platforms other than AWS, or was that kind of like it just felt like the right fit at the time?
I was a certified AWS architect. WR1 requires an AWS platform anyway. Okay. We already use S3 as our object store and so on. Okay. So we briefly looked at Azure, but I'm sure you could do exactly the same thing on Azure. It's just I didn't have the experience, and AWS is already there in the product stack.
What I was really fishing for was your view versus Google versus Azure versus.
I mean, the only things we're using it for are an S3 compatible object store. And you can build one of those yourself out of something like Min.io, can't you? An MQTT based messaging protocol. We'd have to make a few changes to move to something like RabbitMQ or Node-RED. But it's quite like the insides of the device manager, quite nicely designed using object-oriented techniques. I think you saw that quite deep. UML diagram earlier, the class diagram. The internal structure of the devices looks pretty much like that, and the rest of it's all using good Gang of 4 patterns. So changing to another messaging bus would be trivial for us, and that's really all we're using it, and the security obviously.
And so in the life, so you got a 10-year contract with a client for this stack.
Yeah.
And so how often do you find that they're doing things like they'll go and upgrade all their cameras, or they'll go and replace an item and a new protocol you have to deal with and put on?
This product's only been available for a year, so we haven't got to that point.
Okay. I was just wondering what the annual sort of enhancement is in the stack.
The configuration isn't something that we have that we need to do. So something like cameras, they're very simple. Yeah. There's a set of standards called ONVIF, and all of the IP-enabled cameras meet some of those. And I think it's ONVIF G we need, which is a really, really common one.
Okay.
So We got a question on our Q&A. If you can respond, please.
Tiago Bernardi is asking that you comment in your presentation
Yes.
that consume the message in OutSystems. It's not something that is easy. And he's asking how did you manage to do that?
Right. I skipped over that slide, didn't I? Thank you, Diago. Well spotted. How do I get back to the presentation? So, probably everybody who's at home can see this better than the people in the room can. This is the diagram that explains how we did it. So the reason it's easy to send messages is that there's a simple REST API that AWS provides, and it's just going to send this message over there. Trivial, really easy. Consuming them from the browser, we do really want to consume them from the browser because otherwise you have to do it on the server and push the information back out to the browser application. People told me that was a horrible thing to do. It sounds like a horrible thing. So we consume them in the browser, and it requires AWS's token manager to give a temporary credentials out to the application in the browser, which it then uses to connect to the MQTT message bus, which is here, and then listens to the message. I'm afraid that's as much detail as I can go into.
It's a client-side listener that you have on the browser, so it's on a service worker or something that you execute, or on the.
I could only follow the first half of that, but yes, it all happens on the browser.
On the client side, right? So basically, which means that it's some clever JavaScript that exists on the OutSystems application.
And that the culmination of my demo is proving to you that can happen.
Still, if they are still using like the same JavaScript to listen and to then digest the message after when the scale responds, or you change that?
I don't know.
Yeah, because at the time after that AWS and token configuration, I used the JavaScript and with listeners to digest the message because was the user that clicked to get the specific weight of that scale. And then my JavaScript digested the results and then added on the UI side.
Okay.
Hugo did a load of work later on, mostly around the exception handling and that stuff we were talking about earlier.
Before I leave, then was the problem of exception handling, but in terms of digesting, was the same, was the JavaScript with handlers that was digesting the info that is coming from the AWS and that call from the site and the device that you wanted to get the weight.
Okay.
In this case,
But why did you need the JavaScript to handle the message? Because you could get the message. The message is in JSON, right?
Yes.
Yeah. So you could actually move that to a OutSystem kind of structure and use OutSystems to.
More or less because the JSON I needed to work around at the time I needed to work around the JSON response from the AWS because it was not direct. So I needed to do some tweaks to digest that one at the time.
Oh, right. Okay.
So it's why we cannot use direct the JSON. We use JSON at the end, but we need to do some tweaks to.
So here you're just using OutSystems as a UI layer, and inside there is some clever JavaScript.
Yes.
To both send the, sending message you can do using OutSystems REST services, right?
Yes.
Consuming REST services.
But digest
It's the listening part that is missing.
Yeah.
So
As a low-code piece.
my problem at the time was that exception handling that then was solved.
Okay.
But in terms of digesting was the JavaScript.
So maybe this is an idea that you guys can raise in the portal to say that OutSystems should create a listening model for client side.
Yes.
Because it's essentially digesting a message, right?
Yeah.
So it's just have a topic and then probably tokenize a message, and probably for AWS, it's all of the messaging are the same probably structures, right?
And the thing basically, I don't know if it's the same, because the AWS needs to be like secure with that token. We did an application to do that part of the configuration, and then the JavaScript just really need to send a message and digest because was we got the web lock on the screen with that part of the tokenizer to be a free way of listening and sending.
Okay.
So I was at a OutSystems session a few months ago, which talked about integration with AWS services, and it appears to be a fairly big thing for OutSystems' future.
Yeah, no, I mean, the all the services, we have lots of components to integrate with the services on the Forge, but for things like, what do you call interactive messaging like this,
Yeah.
because it has to happen on the client side, we cannot implement that on the server side.
Yeah.
Right, so which means that the developer still needs to write either some JavaScript on the service worker, which is running on the background, or you have to write something clever on your application to constantly listen. So, and that's a low code piece, I think, that we are missing from the integration point of view.
That'd be great, yeah. It comes up quite often as a thing you need.
I still haven't seen that. I think the biggest requirement I have seen for this is in-app messaging. That's why we integrate with lots of in-app messaging providers, which does handle all of this on a clever JavaScript that they provide.
Right.
Whereas out of the box on OutSystems, I believe that this is a missing feature.
Yeah. Yeah, I was just about to ask how you do that in app messaging.
Yeah.
I've seen that.
Firebase.
Yeah, 5 days. I mean, you have to write the service worker side to listen to this. I did that on one of the examples to write and listen, and it doesn't always work. So because there can be errors, right, when you get the message, and plus you have to make sure that you are actually sending the message to the device ID itself, and then those kind of Firebase allows you to do that, but it needs to be clever JavaScript.
Yeah, and the trick here is the UI at the time was that specific scale and that specific site, so you can control that flow better.
Yeah, okay.
Are you in reactive or traditional web?
It must be reactive.
Yeah.
It's reactive.
Otherwise, writing
No,
JavaScript in
no,
traditional
it's
way
reactive.
would be crazy, yes.
Actually, at the time, this I think, Phil, correct me if I'm wrong, this is still on the only application that is on reactive in WR1. Or you already
In WR1, it might be one other application now. I've been running a project this.
Yeah, and
It's there.
but yeah, basically this was the first project in reactive at the time.
I've been project managing and product owning an entirely reactive project part-time this year as well. So that's not part of WR1, it's independent of it.
Yeah.
Is anybody starting traditional applications these days?
I don't think so.
But they cannot,
They
because
look
the new
like-
licensing doesn't even allow to.
We follow the license, but
No, the old license can, but
it
if
wouldn't
you
be
want,
advised because they're gonna change, so
There are,
companies spend time developing anything traditional, will be, let's say, forced to upgrade in a bit of time and change
you want to
everything
show
to
something
reactive.
more, or I can close the eye really.
If you give me 5 minutes, I'll just do a get weight from our scales, and then I'll do the same thing actually in an OutSystems application. I said I was going to finish by showing you it actually working from OutSystems.
Yes, but for some, I think it was Thiago that was asking that the low-code part is very minimal here.
Yeah.
But when this project started, was me and João, and we have a scale like the one from the post office, and we managed to do an integration. We did I think 3 types. We did in C#, we did in Python,
and WebSocket.
yeah, Python and JavaScript, and you connect the application generated in OutSystems, reading the weight from the scale, or we use a Raspberry Pi that you could read everything from the internet, or we use, for example, the C#, where you connect the scale direct to our PC, and we create, I think if not wrong, was Flask
plus
Yes,
Python and Python.
Then you
REST
could
API, yeah.
read every information, parse, and present the weight.
And
using-
basically, it was just a simple REST API
Yeah.
to.
Then when if you arrive to the company, so that there was more requirements and this need to go to the cloud, and it was not like the POC that we are trying to prove at that point in time.
So what you're basically saying is all the money is in IoT integration. Just put focus on that area because that's where there's no simple solution that you've got to like, you know what you're doing.
I think it's only when you start working on it, you will find them more easy. Of course, in the beginning, these were like,
Yeah, I can imagine.
yes. And even when I started the first digest JavaScript to do that, was not easy, but then when the result comes is when you are happy.
So this is ES6 or you're using ES6 or is it JavaScript, the latest version of JavaScript? Because OutSystems JavaScript, what do you call it, they didn't support in the past ES6. It's only
No.
recently that we support.
Yeah, I know, was with the old version.
Okay.
But you comment about the message from one side to another. I was involved in a project recently, and we use one of the Forge component SSE, push event, hub and client. And our proof of concept was, for example, we create something in OutSystems. Then we have another application developed in Android that was reading something in our screen. And this application had an API and sends the messages to the backend. And when the backend received the messages, it sent the message to our page, and our page will go into the direction that we asked it to.
But what backend was this? This isn't, the backend was not on OutSystems.
No, it was in OutSystems. Use the SSE push event. It's like have a web log that when you generate the page, you start to listen.
Yeah, but where did you send the payload to backend what?
Now we have an Android app that reads the QR code with the information that we had, and inside of the QR code we have an address to call it back. Then after process everything that was necessary in the Android was calling again this API
Oh,
that was in our systems.
Okay, while all that was going on, I started up a device manager running actually on my laptop from in my development environment, and it started up, and here you can see the messages that come out as it starts up, and it finishes up with, yes, I'm running. I've talked about all that before. I'm now going to, for reasons of time, I'm going to skip a few bits, but I'm just going to ask it for the weight on the scales in our test weighbridge with a truck. It's got a truck on it with a load of electronic waste actually. And there you see the result message coming back. And it's got, I asked for the device with ID 1001. It came back and said, this is the result for ID 1001. That's how you link the messages together. So you know you've got the response that you want. It's got 0.96 kilograms, no serial number, and a timestamp on it. So, as you said, trivial to parse into JSON. With the async API specification that I was talking about earlier, in a lot of languages you can just generate what we do for the device manager, we just generate the code for dealing with and parsing these structures. It would be really nice to be able to generate structures like that in the OutSystems. I can't say that's a massive problem, but it's a good one. Now I'll show you our weighbridge, because you're probably thinking that's not very heavy for a truck with electronic waste in it, is it, Phil? And that's our weighbridge. So, and to end, I'm going to attempt to actually use an OutSystems application. That's something I might come back and talk about later, but not this year. This is our product. Now, one of the other things I'm very keen on is automating testing. We've been using BDD a bit in the compliance tracker. If anybody wants my opinion on that, I could talk for 2 hours, but you won't enjoy it.
Why is it still in traditional web?
That's the first
I
question.
think it's updated now.
I've been banging on with those guys for
I think it's
3 years
updated.
about that, yeah. So annoying, you
That's
train a
all
bunch of
right.
grads, and then they have to use the BDD things and track over and they don't have to deal with it, right?
But one of the things I've done is I've created some virtual scales which just run on an EC2 server, and respond. They look like real physical scales. I modelled them on some ones that I just have access to in Australia, and they just sit there answering questions. This one proves we've got some error messaging on there. Whee! That's bad configuration. That just says, I was expecting to get a number at this point in the message, and I didn't get it back. This one, well, there's nothing on there yet, but in my imagination, a truck has just drawn on. It's quite a light truck though, and gone off again. A much bigger truck. So my test scales just cycle through those readings, but that proves that you can that you can pull the scales from an OutSystems application using all the shims that Joe and Hugo and other people have done, and I can't really explain. Not exactly fireworks, but I hope that's been interesting to you. It's a bit different from the other things I've seen OutSystems used for, and so I hope it has been interesting. Are there any more questions?
Online, maybe they're being very shy. Right?
Well, you just cover with something, what was it?
Yeah, we talk more about everything out of OutSystems, and most of the guys here usually are like focused too much in OutSystems.
I think also it's important to focus
Oh,
on
yeah.
this area because
Because you turn up to one of these, you're probably pretty proficient with the platform, you won't know when we stuff at the end.
Yeah, correct, yes.
So I mentioned to one of my friends he's quite a low-level developer of very, very advanced video editing kit, and he's a pretty good computer scientist. And I told him that I was running a project in OutSystems, in low-code environment, and his initial reaction was, "Good luck." And I went, "Why is that then?" And he went, "Well, it seems that those platforms can do about 80% of what you might want to do.
Which is often 99%.
And it's that last 20% where you're trying to integrate with the things that the low-code environment won't do. And this is an example.
That's why it's low code, right?
Yeah. And that's one of our system strengths is the ease with which you can integrate something. I've got some horrible data algorithms in this other project I've been running. And the idea of writing and testing those in OutSystems filled me with horror. And I saw, I know you might have seen some code in the scheduler that Carlos has written. And it's just horrible with these massive switch statements in, and it's virtually impossible to test. So I just wrote those in C# and wrote some C# unit tests for all of them to make sure they gave what I wanted. It's a case of picking the right tool for the job.
Yes.
So I just gave that extension to the OutSystems developers and went, there you go, just plug into that. They did find one defect, didn't you, Mario?
and the thing is, if you want to use OutSystems 300%, you need to do this kind of stuff outside the platform as well to enjoy even more. You can deliver 100% in one, but if you want to do the next level.
Yeah, because this is where the creativity is, right? So this is where the real talent is required.
Thank you.
Right, so where the interface part is, that's what we aggregate and, just very quickly show something where we are doing the same thing again and again. Whereas it's far more precise and needs a specialized skills.
Yeah.
Right, so.
Oh, thank you very much.
Thank you.
Obviously, I'll be around for a bit longer.
Thank you. Let's open this door because
It's getting warm here.
Let me just close the event.
Come on, the windows, you really can't get a
So, guys, we are closing the the virtual event. So I hope you guys like this presentation. Any questions, just ping me or the organizers on the OutSystems community. If you have any doubts or feel, or just in your comments after that you are receiving about this event, just give us your feedback. Thank you guys. Have a nice evening.
Thank you.
Bye.
Guys.
Bye. Have a nice evening. Bye.
Bye.